Of class 12. Today we are going to discuss the example 3.10, in which it is being asked that what is the potential across the arm AB, where B is the variable point on the potentiometer, that is the point of the slide, when a battery of potential V is applied across the potentiometer, having total resistance R0 as you see in the diagram. Now in this case we have to find the potential across point B, AB, when the slide is in the middle of the resistance coil R0 of the potentiometer. For that, in this case, when half of the resistance is used, so between the arm AB of the potentiometer, so the total equivalent resistance of the parallel combination of R0 by 2 and resistance R is given by the relation 1 by R is equal to 1 by R plus 1 by R0 by 2, and that becomes equal to, that gives R1 barabar equal to R0 R by R0 plus 2R. Now this is the equivalent resistance of the parallel combination, and since the current is drawn across the arm BC as well, therefore now a resistance of R0 by 2 should be attached in series. That will give us the total resistance of the circuit applied across this cell. So we have to find the total resistance becomes the series combination of R0 and R1 and R0 by 2, and now we can find that total current draw using the relation V is equal to IR. We can find that total current drawn through the potentiometer will be the V potential is applied across it, and a resistance of R1, that is the equivalent resistance of R and R0 by 2, plus R0 by 2, the remaining part of the potentiometer, that is from point B to point C, the resistance R0 by 2 is added. And so when you divide the total potential applied by this factor, we get the current drawn from the cell. Now once we know the current drawn from the cell, we have the potential drop across the point AB. Potential drop across the point AB will be equal to current drawn from the cell multiplied by the resistance across AB. And you know that current drawn we have just seen is 2V by 2R plus R0, and that multiplied by R1, the equivalent resistance of parallel combination, gives us the total potential drop across the point AB. And so on putting the value of R1 and solving, we get the total potential drop across the point AB when the slide is in the middle of the potentiometer is equal to 2VR by R0 plus 4R, where R is the resistance in parallel to the potentiometer and V is the potential of the battery applied across this combination of resistances, and R0 is the total resistance of the potentiometer. Thank you and have a nice day.